Plastic waste is piling up in the world's landfills, sewer systems, and in the ocean.
Plastic pollution is destroying life in the ocean.
A gigantic swell of trash floating in the Pacific Ocean.
And human coastal communities.
We see plastic everywhere.
Some of the places being hit hardest are small island states.
Small island developing states contribute minimally to a lot of environmental challenges, but are impacted the most.
So what do these countries reveal about the problem and the answers urgently needed to solve it? On a small island in Fiji, Sam is a fisherman who depends on the sea.
My community connection with the sea it's our daily life.
The majority of Fiji's population live near the coast, and many are all too aware of an increasing scourge in the water: plastic pollution.
When we go to the sea, even the coral, you'll see the plastics there. The fish that usually stays in the coral, they are not there anymore now. And usually the fish we catch, you can catch it now. There's a lot of plastic. It's been polluting our ocean a lot.
I think Fiji has definitely changed due to plastic pollution. I believe that it's gonna bring many problems in the future.
Fiji is part of a group known as Small Island Developing States, or SIDS. These islands have a combined population of just 65 million and suffer the consequences of plastic pollution disproportionately. That's because plastic pollution damages the industries their economies depend on: fishing, but also tourism.
A lot of the plastic waste that washes ashore small island developing states affects our tourism. We're dealing with small economies already vulnerable to so many environmental challenges: climate change, rising sea level, and economic growth.
Globally, humans produce around 350 million tons of plastic waste per year, a figure projected to almost triple by 2060. It's estimated around 11 to 14 million tons ends up in the ocean. So how is this plastic getting into the water? Some does come from small islands. Per person, the Caribbean is one of the highest emitters of plastic to the ocean. The challenge for small islands across the world is overflowing and unregulated landfills like these. With limited space, dump sites are often close to the coast and the main option for getting rid of waste.
There are leakage issues because of unsound waste management and low resources. There's a limited land space for landfill capacities and low resources for recycling, which leads to an acceleration of the plastic waste in country.
But most plastic pollution in the ocean is not coming from small islands. Pacific Island countries produce less than 1.3% of the mismanaged plastics in the world's oceans, yet are one of the main recipients. A lot of plastic pollution washes up on the shores of small islands because of ocean currents.
I'm interested in the dynamics of how the ocean actually moves.
Professor Eric van Sabeel was one of the first to use simulations like this to show how and where currents lead to hotspots of plastic in the ocean.
We developed simulations of how the ocean currents move plastic from one location to the other location. What we see is that a lot of the plastic stays near shores. And then some of the plastic eventually ends up in the centers of what we call the subtropical gyres. There are 5 of them, one in the North Pacific, one in the North Atlantic, and then 3 in the South Pacific, the South Atlantic, and the Indian Ocean.
Large areas of the ocean and many coastlines are badly affected, but his research backs up the idea that many small islands suffer especially from plastic pollution.
So I think that SIDS are particularly impacted by plastic pollution, and that's both on the effect that it has on their local economies, but also because those SIDS are in the middle of the ocean there, where there's a lot of plastic floating around that may end up on their coastline.
The Seychelles is a group of islands in the Indian Ocean which are particularly affected by ocean currents. On the Aldabra Atoll, one of the country's largest marine protected areas, scientists from Oxford University collaborated with the Seychelles Islands Foundation to collect data on the source of pollution.
As you can see, the beach crest is absolutely covered in marine debris. Because Aldabra is not inhabited, we know that none of the plastic that's arriving on Aldabra is actually coming from Aldabra.
This simulation, created by the scientists, shows how debris enters the ocean from countries such as Indonesia, India, and Sri Lanka. Some of that debris makes its way to the Seychelles via ocean currents. The scientists also found another big source of waste on Aldabra: industrial fishing.
We found the majority of waste by weight was from the industrial fisheries. Big ropes, nets, buoys, discarded barrels.
The team removed 25 tons of rubbish, but estimated this was just 5% of the total amount on the island.
One of the biggest things that we noticed was that the turtle nesting beaches were so clogged with plastic that it was actually putting the turtles off from nesting there. The whole of Seychelles is impacted by plastic pollution. And this is a global problem that's arriving on their shores on a scale at which they're not able to deal with.
Although the fishing industry is a major cause of this global problem, research suggests the biggest sources are rivers in polluting countries in Asia. Those studying the hotspots in the ocean say tracking the different sources of this pollution is vital. It means the polluters can be named and shamed.
One of the things that I really want to do with the simulation is run them in backward mode and then essentially play the blame game. And then we can assign a probability, a chance that it comes from, say, a certain river, from a certain fisheries area, from a certain country. Then we can maybe start thinking about litigation and really get the blame game into court.
But what are islands themselves doing to get rid of plastic in their own backyards? There's one simple and obvious thing: beach cleanups. These are now common on islands across the world, and they also help in ways that the naked eye cannot see.
And every time that plastic goes back and forth, on the sand, on the rocks, that is where microplastics are actually created. And that means that cleaning up coastlines is actually the most effective way to clean up the ocean. Then you prevent it from getting back into the ocean as microplastics.
Countries can also go further and ban some ways that plastics are used. One tiny Pacific island has led the charge here. Vanuatu was one of the first countries in the world to enforce a single-use plastic ban, and it now has some of the toughest plastic restrictions in the world. In 2018, it banned items such as single-use plastic bags, plastic straws, and takeaway containers, with more items added to the list since.
Since the ban, there is a big change. Before we have many plastic bags, but now we have none.
Regina is a local weaver who says she is benefiting from the bans by selling bags made from alternative materials, such as the leaves from local trees.
When we free the plastic bags, it developed my business. With our country free from the plastic, we can do many different kinds of things more apart from this.
And on Vanuatu's beaches, Dr. Christina Shaw has measured the success of the bans.
So that's fishing line. So you get a sort of everything mixed up together and then tangled.
2, 3, 4, 5.
And the plastic?
During beach cleanups, banned plastic items now make up 2% of recorded litter. Before the bans, that figure was 25 to 35%.
I think one of the big things that some of these small island nations have done is actually stepped up and made the decision. They go, no, it is a problem. We're going to ban these plastics. We're going to do what we can do. And I think that is a lesson for the bigger governments as well.
However, it's near impossible for any country, especially inhabited small islands, to survive without any plastics.
It's difficult for small island nations to be completely plastic free because we're not in control of the whole life cycle of plastics. All of our plastics are imported. By far, the biggest item we have is plastic food packaging. So, you know, your noodle wrappers, lolly wrappers, chewing gum wrappers. We're reliant on the innovations in other nations and other big companies to make so that it makes it easier for us to try and become plastic free.
Now, more than 120 countries across the world have bans and taxes on various single-use plastics. These include big countries such as India and Canada, as well as small islands in the Pacific, Caribbean, and beyond. And while this has brought some reduction in waste, banning plastics can pass the buck. Switching to alternative materials can create other waste problems. So, it's vital to get better at reusing and recycling plastics. Globally, only 9% of plastics are recycled, 19% incinerated, 22% mismanaged, and 50% end up in landfill. On small islands, recycling is tricky because they lack the infrastructure and space. It requires sending waste abroad, often long distances, and that's expensive.
We know we need to develop recycling capabilities. I think we need to talk about the resource needs, the gaps, the challenges, and the avenues for support if we are to ever solve this problem.
And there's another much bigger global challenge here. Current recycling methods, even in rich countries, are a bit rubbish. Most plastics can only be recycled 2 or 3 times before they become unusable and end up in landfill. To solve the world's plastic problem, what's needed is a new technology to improve recycling, one that depends on work far beyond the shores of small islands.
What we really need is a recycling process that takes that material back into virgin-like properties so that it can be used in the original application again and again.
Professor John McGeehan and his colleagues have been working on just that, a whole new approach to recycling. At the University of Portsmouth on Britain's south coast, they have been identifying and engineering what are known as plastic-eating enzymes. These can break plastics down into their original component molecules, which can then be used in infinite cycles.
What we're looking for is more circular technologies that can really generate the building blocks and allow us to infinitely use that material again.
Teams of researchers across the world are searching for these enzymes that can break down common plastics. Many are looking in pollution hotspots like Indonesia and the Philippines, and also on small islands like Singapore.
The best place to look for enzymes that can digest plastic is places like beaches, corals, and particularly mangroves, places where there's high areas of plastic pollution. We've been working with colleagues all around Southeast Asia, particularly based in Singapore, where there's groups there that can go out into the field. And in those areas, we're starting to see enzymes that are developing, evolving, that can eat the plastics themselves. And we can actually then bring them back to the laboratory, identify the enzymes, and then engineer them to be faster.
Plastic-eating enzymes have great potential to reduce waste, although the technology is still a long way from being used at a global scale, and from overcoming the infrastructure challenges linked to current recycling practices.
We need to develop technologies that are scalable, but also are deployable into the areas where plastic pollution exists. And we think that's possible. We think we can actually miniaturize some of the solutions so that local communities can potentially degrade plastics and get chemicals out of those that they can then sell and actually give back to the local economy.
Plastic pollution is ultimately the world's problem. and new levels of global cooperation are needed to solve it. Although small island states have led calls for action, richer and larger countries will determine whether this happens.
We will have a strong global, international and comprehensive framework on plastic pollution.
In 2022, a UN resolution was signed by 175 countries, committed to developing a global, legally binding plastics treaty by the end of 2024. This promises to cover production, packaging, design and disposal of plastics. But for now, it's just talk and no walk.
Without coming together, we're going to see fragmented approaches. We're going to see a proliferation in this issue that would lead to unsustainable levels of plastic pollution.
We're hopeful the treaty will make a difference, but it has to be strong enough to do so.